Your joints are not worn out. That is the story you have been told. Wear and tear, age, overuse. The implication being that your joint pain is simply the mechanical consequence of a body that has been used. That nothing can be done except to manage the pain and wait for the damage to worsen. That story is incomplete, because research published in Frontiers in Cell and Developmental Biology in January 2026 confirmed what decades of joint research have been pointing toward. Oxidative stress and chronic inflammation are the core mechanisms jointly driving the pathological process in arthritis. Not simply wear and tear, not simply age. A specific, researched, cellular inflammatory process that has a mechanism and a food-based approach that studies indicate may influence it. Your joints are not worn out, they are inflamed, and inflammation has a cellular cause. And cellular causes have cellular solutions. Welcome to Cellfresco. One belief drives everything we do here. Every cell has a healing food. We do not make food lists. We explain what food says to your cells, because every meal you eat is sending biological instructions to the cells inside your joints. Some signals inflame them, others appear to repair them. Today we go inside your joint tissue to show exactly how chronic inflammation may be destroying your cartilage, your synovial membrane, and your bone at the cellular level, and the specific foods that studies indicate may send healing signals to each mechanism. Here is exactly what we will cover today. First, the research, what 2026 science confirms about inflammation and joint destruction at the cellular level. Second, 3 specific cellular problems that chronic joint inflammation may be creating. Third, 3 specific foods, and how studies indicate each one may target a specific cellular mechanism. Fourth, what to eliminate and exactly why each one appears to worsen joint inflammation. And finally, your daily protocol and action plan. Now the story. Your joints contain a remarkable structure called the synovial membrane. This thin tissue lines the interior of your joint capsule. Its job is to produce synovial fluid, the lubricating fluid that allows your joint surfaces to glide smoothly, and to provide nutrients to your cartilage, which has no blood supply of its own and depends entirely on the synovial membrane for its maintenance and repair. In a healthy joint, the synovial membrane is thin, quiet, and efficient. Cartilage is thick, smooth, and resilient. Bone ends are protected. Movement is effortless and pain-free. But research from the GK University School of Medicine confirms what anyone with chronic joint pain already knows through experience. When inflammation enters the joint, the synovial membrane transforms. It becomes thickened, hyperplastic, and aggressively inflammatory. Immune cells, particularly macrophages and fibroblasts-like synoviocytes, begin proliferating in the synovial tissue. And these activated cells produce an inflammatory cascade that research confirms can destroy cartilage, erode bone, and drive the progressive joint damage that conventional medicine struggles to slow. And the driver of this entire process, the same NF-kappa B inflammatory switch we have discussed across this series, is now activated inside your joint tissue, producing TNF-alpha, IL-1-beta, and IL-6. The inflammatory molecules that research confirms drive cartilage destruction and bone erosion. 3 specific cellular mechanisms, each one a specific target. The goal is not simply to reduce pain. The goal is to change the signals your joint cells are receiving every day. Cellular problem 1. Synovial inflammation may be filling your joint with destructive inflammatory molecules. When NF-kappa B is activated in synovial macrophages and fibroblast-like synoviocytes, it produces TNF-alpha, IL-1-beta, and IL-6 directly into your joint environment. These cytokines do not just cause pain and swelling. Research confirms that TNF-alpha directly activates the cells that destroy cartilage called chondrocytes, causing them to produce their own destructive enzymes called matrix metalloproteinases, or MMPs. These enzymes digest the collagen and proteoglycan matrix of your cartilage. The very structural proteins that give cartilage its resilience and cushioning capacity are being actively broken down by enzymes that the inflammatory process produces. IL-1-beta further activates chondrocytes and synovial cells to produce more MMPs, and IL-6 stimulates the production of cells called osteoclasts that erode the bone beneath your cartilage. The joint pain you feel is the surface experience of a specific cellular inflammatory cascade that research has now mapped in precise molecular detail. Cellular problem 2. Chondrocyte dysfunction may be preventing cartilage repair. Your cartilage contains cells called chondrocytes, whose job is to maintain and repair the cartilage matrix. Every time you bend your knee, climb stairs, or grip an object, you are relying on millions of chondrocytes to maintain the smooth surface that allows painless movement. In a healthy joint, they produce collagen type 2 and agrecan, the structural proteins of cartilage, and they degrade old damaged matrix at a carefully balanced rate, But research confirms that chronic inflammatory cytokines, particularly IL-1 beta and TNF-alpha, shift chondrocytes from a repair state to a destructive state. In this state, chondrocytes produce more MMPs, more inflammatory molecules, and less collagen and aggrecan. The cells responsible for building cartilage have been converted by chronic inflammation into cells that break it down. And research published in the International Journal of Molecular Sciences confirms that oxidative stress inside chondrocytes, driven by the reactive oxygen species that inflammatory macrophages produce, further impairs the chondrocyte's ability to synthesize the matrix proteins cartilage needs to repair and maintain itself. Cellular problem 3. RANKL activation may be driving bone erosion beneath the cartilage. As joint inflammation progresses, research from the GK University School of Medicine confirms that activated synovial fibroblasts and T cells produce a molecule called RANKL, receptor activator of nuclear factor kappa B ligand. RANKL signals to precursor cells to differentiate into osteoclasts, the bone-destroying cells, and activated osteoclasts begin eroding the bone that lies beneath the already damaged cartilage. This is the cellular mechanism of the joint erosion visible on X-rays in advanced arthritis. It is not simply wear, it is an active, RANKL-driven bone destruction process that research confirms is initiated and maintained by the inflammatory cascade originating in the synovial membrane. 3 cellular mechanisms, each one driving joint destruction through a specific molecular pathway, and each one with a food that studies indicate may send a counter-signal. Food 1. Ginger, the synovial inflammation suppression signal. Ginger contains bioactive compounds called gingerols and shogaols, and these compounds have been shown to target the joint inflammation cascade through a specific mechanism. Research confirms that gingerols and shogaols can inhibit NF-kappa B activation in synovial macrophages and fibroblast-like synoviocytes, reducing the production of TNF-alpha, IL-1 beta, and IL-6 directly in the joint environment. But ginger does something additionally specific to joint tissue. It appears to inhibit the COX-2 enzyme, the same enzyme that anti-inflammatory medications target, through a dietary pathway rather than a pharmaceutical one. COX-2 produces prostaglandins that sensitize joint nerve endings to pain and promote synovial inflammation. Inhibiting COX-2 through gingerols may help reduce both the inflammatory molecules damaging cartilage and the pain signals produced by joint inflammation simultaneously. Research from multiple clinical trials suggests that ginger supplementation from whole food sources is associated with measurable reductions in joint pain, swelling, and inflammatory markers in people with osteoarthritis and rheumatoid arthritis. Every serving of fresh or dried ginger may be delivering gingerols and shogaols directly to the inflammatory cascade that is driving destruction inside your joint tissue. 1 to 2 teaspoons of fresh or dried ginger every single day, consumed in food, tea, or warm water. Your synovial inflammation suppression protocol? Food 2. Tart cherry, the chondrocyte protection signal. Your chondrocytes have been converted by inflammatory cytokines from cartilage builders into cartilage destroyers, and tart cherry is among the most studied foods for supporting healthy chondrocyte function. Tart cherries contain anthocyanins, particularly cyanidin-3 glucoside and cyanidin-3 rutinoside, in concentrations significantly higher than sweet cherries. And research from multiple studies indicates that tart cherry anthocyanins can inhibit NF-κB activation in chondrocytes, reducing the production of MMP enzymes that destroy the collagen matrix of cartilage. Research also suggests that tart cherry anthocyanins may help reduce the oxidative stress inside chondrocytes that research confirms impairs their ability to produce the collagen and aggrecan that cartilage repair depends on. And multiple clinical studies have found that regular tart cherry consumption is associated with measurable reductions in markers of cartilage degradation, reductions in uric acid levels relevant to gout, and reductions in inflammatory markers in people with joint pain. Every cup of tart cherry juice may be delivering anthocyanins to your chondrocytes, where studies indicate they can help restore the repair function that inflammatory cytokines have suppressed. 1 cup of pure tart cherry juice every single day, your chondrocyte protection protocol. Food 3. Broccoli, the bone and cartilage preservation signal. The RANKL-driven bone erosion beneath your cartilage is the final stage of the joint destruction cascade, and the single most researched food compound for targeting the RANKL pathway is sulforaphane from broccoli. Broccoli contains glucosinolates that are converted in the body to sulforaphane. And sulforaphane has been shown in laboratory and preliminary human studies to inhibit the inflammatory pathways that activate RANKL production in joint tissue. Research also indicates that sulforaphane may activate the NRF2 pathway in chondrocytes and osteoblasts, the bone-building cells potentially supporting the oxidative stress defense that these cells need to function correctly in an inflamed joint environment. Research published in Arthritis and Rheumatism found that sulforaphane from broccoli was associated with reduced cartilage degradation markers in ex vivo joint tissue studies. And research from multiple institutions suggests that regular cruciferous vegetable consumption is associated with reduced arthritis risk and reduced joint inflammation markers in population studies. Every serving of broccoli may be delivering sulforaphane to the cellular pathways that appear to inhibit the RANKL-driven bone erosion and support the NRF2 antioxidant defense in joint tissue. A cup of broccoli 4 times per week, lightly steamed to preserve sulforaphane content. Your bone and cartilage preservation protocol. Now your daily protocol. 3 foods, 3 cellular signals every day, morning or with any meal. 1 to 2 teaspoons of fresh or dried ginger. Your synovial N, FKB, and COX 2 suppression signal. Daily. 1 cup of pure tart cherry juice. Your chondrocyte protection and MMP suppression signal. 4 times per week. A cup of lightly steamed broccoli with any meal. Your NRF2 activation and RANKL pathway inhibition signal. What to eliminate and why each one appears to worsen joint inflammation. Sugar and refined carbohydrates produce advanced glycation end products that research confirms directly activate NFKB in synovial tissue, worsening the inflammatory cascade producing the MMP enzymes destroying your cartilage. Processed foods rich in omega-6 fatty acids fuel the arachidonic acid pathway that produces the prostaglandins and leukotrienes driving joint pain and synovial swelling. Excess alcohol has been shown to increase uric acid levels and systemic inflammatory markers, both of which worsen joint inflammatory processes. Red meat in excess contains arachidonic acid that research indicates may fuel the COX2 pathway in joint tissue. These are not simply foods to avoid, they are direct inputs into the cellular mechanisms actively destroying your joint tissue. Your action plan: 3 cellular problems, 3 healing signals, 3 opportunities to help your joint tissue move back toward balance. Ginger every day. Your synovial NFKB and COX2 suppression signal. Tart cherry juice every day. Your chondrocyte protection and cartilage, MMP reduction signal. Broccoli 4 times per week. Your RANKL pathway inhibition and NRF2 joint tissue protection signal. Start tomorrow. Ginger in your morning drink. Tart cherry juice with breakfast. Broccoli with dinner this week. Your joints may not be worn out. They may be trapped in a chronic inflammatory cycle. And every day, your food choices may be influencing that cycle. Inflammation is a cellular process with specific cellular causes and specific cellular countersignals that specific foods appear to be able to deliver. If this video showed you that joint pain has a cellular cause that nobody explained to you, please give it a thumbs up. It helps more people find this channel and it means everything to us. Subscribe to Cellfresco. Every cell has a healing food, and every week we show you exactly which one. Keep healing, keep thriving.